By the end of this lesson, you should be able to determine the relationship between volume and temperature at constant pressure for a fixed mass of gas, that is, V over T equals to constant. Explain absolute zero. Explain absolute Kelvin scale of temperature. Look at the empty container floating in the sea. As the day gets hotter, the volume of the trapped air increases. Why is it so? How does the temperature influence the volume of the trapped air? Move the slider to increase the heat supplied to the container of gas. Observe what happens when the piston of the container is not allowed to move. When the gas is heated, the average kinetic energy of the molecules increases and the molecules move faster. Since the piston is not allowed to move up, that is, since the volume of the gas is kept constant, the frequency of collisions between the molecules and the wall in the limited space will increase. The pressure of the gas, therefore, builds up. Now, move the slider again to increase the heat supplied to the container of gas. Observe what happens when the piston of the container is allowed to move. If the gas is allowed to expand, the faster molecules now move in a bigger space. The frequency of collisions with the walls will not increase but remain as before. Therefore, the pressure of the gas remains constant, while the volume of the gas increases with temperature. In the previous simulation, with the pressure of the gas kept constant, the variation of volume with temperature is plotted, and the following graph is obtained. The graph is a straight line that does not pass through the origin. If the graph is extrapolated backwards, where does it cut the horizontal axis? V equals to 0. When the graph is extrapolated backwards, it cuts the horizontal axis at the temperature of -273 degrees Celsius. At this temperature, the volume of the gas becomes 0. This temperature of -273 degrees Celsius is known as the absolute zero of temperature, because it is supposed to be the lowest temperature possible. The gas particles theoretically stop moving and have 0 volume. If we shift the vertical axis to the left, we obtain a graph with a straight line passing through the temperature negative 273 degrees Celsius. We renumber the temperature scale, making negative 273 degrees Celsius as the 0 on a new temperature scale. This new temperature scale is known as the absolute or Kelvin scale of temperature because it starts with the absolute zero of temperature, that is, negative 273 degrees Celsius, or now also known as 0K. The graph of volume against temperature in the Kelvin scale is a straight line passing through the origin, if the pressure and mass of the gas is kept constant. This means that for a fixed mass of gas at constant pressure, the volume of the gas is directly proportional to its absolute temperature. This is known as Charles' law. Charles' law can be stated in a mathematical equation. V is directly proportional to T. That is, V over T equals to constant. That is, for a fixed mass of gas at constant pressure. To convert temperature in the Celsius scale to the Kelvin scale, add 273 to the Celsius temperature. That is, theta degrees Celsius is equal to 273 plus theta Kelvin. For example, 0 degrees Celsius equals to 273 Kelvin, 100 degrees Celsius equals to 273 plus 100 equals to 373 Kelvin. A cylinder contains 200 cubic centimeters of gas at a temperature of 27 degrees Celsius. The gas is heated until its temperature increases by 30 degrees Celsius. If the piston of the cylinder expands under constant pressure, what is the final volume of the gas? Let the initial volume of the gas be V1 and its temperature be T1. Let the final volume of the gas be V2 and its temperature be T2. According to Charles's law, V over T is a constant, or V1 over T1 is equal to V2 over T2. Can we use T1 equals to 27 degrees Celsius and T2 equals to 57 degrees Celsius in this formula? No, we take T1 plus 273, which equals 300 degrees Kelvin. T2 equals 57 plus 273 equals 330 degrees Kelvin. V1 equals 200 cubic. Therefore, 200 over 300 equals V2 over 330. Or V2 equals 200 over 300 times 330. Therefore, the final volume of the gas, V2, equals to 220 cubic centimeters.
In this experimental setup, a volume of gas is trapped by a column of concentrated sulfuric acid in a capillary tube. Ice can be added into the water to lower the temperature, or the heat can be turned up to increase the temperature. Click on the buttons to lower or increase the temperature and observe how the volume of the trapped air changes with temperature at constant pressure. When the air trapped in the capillary tube is heated, the kinetic energy of the air molecules increases. They move with higher velocities, bombarding the walls of the tube harder and more frequently. This resulted in an increase of pressure of the trapped air. This high-pressure air then pushes against the column of concentrated acid. The volume of the air column increases until its pressure equals to the atmospheric pressure. The higher the temperature, the greater is the volume of the trapped air.